Hi, this video is about mixtures. We're going to define them and we're going to talk about how you can separate them. All right, so first of all, the definition of a mixture is it is a combination of two or more substances. Each substance keeps its own identity and they are not chemically combined. Because they're not chemically combined and because they each have their own identity, we can separate a mixture. So components in a mixture are not chemically combined. They can be classified as homogeneous or heterogeneous. So a heterogeneous mixture is one where every sample that you would take of the mixture would not be identical. So they do not have the same composition, properties, or appearance throughout. So I like to think of a heterogeneous mixture as something like a chocolate chip cookie. Not every single bite is going to be exactly the same. A homogeneous mixture are mixtures that are uniform throughout, and we call a homogeneous mixture a solution. And I like to think of that as something like, oh, sweet tea or something like that. So here's a picture of some dirt. Would you classify that as homogeneous or heterogeneous? Well, if I took a handful of dirt and say my lab partner took a sample of dirt, are we going to have exactly the same stuff in our sample? I might have a worm, he might have a stick or a rock in his. So dirt would be classified as a heterogeneous mixture. On the right are test tubes with different solutions in them. I kind of gave away the answer there, but it's something that's been dissolved in water. That pretty blue color, the cobalt blue one, possibly could be copper 2 sulfate. It's a salt that would be dissolved in water, and it could be uniform throughout if I mixed it up really, really well. So those would be homogeneous or solutions. All right, so let's talk about how do we separate mixtures. All right, there are 3 different ways that I'm going to talk about that you can separate a mixture in this video: filtration, distillation, and chromatography. So first of all, filtration. You may have done this. If you make coffee, you are actually filtering the coffee beans out of the coffee. It just so happens when the water is hot and it passes over the coffee, you get some of the flavors that come from those coffee grounds. But filtration is a mixture of a solid and a liquid. You pour it through a porous paper, like a coffee filter. The liquid's going to go straight through the paper and the solid's going to remain behind in the paper. So here's just a picture of how we filter things in chemistry. We have a funnel, and inside the funnel we put a piece of filter paper, and then we will dump our mixture in there. The solid will stay behind in the funnel, and the liquid goes right through. And what comes out, the liquid that comes out in the bottom, we call the filtrate or the filtrate. Okay, distillation. This is a process that depends on the differences in volatility of the components of the mixture. And what we mean by that is how easily something is converted to a gas. So it's kind of based on different boiling points. So here is a distillation apparatus. It looks pretty complex, and we will not use one in this class, but if you ever take organic chemistry, you'll do a lot of distillations. All right, so here's our flask. Let's pretend we have alcohol, has a lower boiling point than water, and water. So we'll heat it up. And so the alcohol will start to vaporize or boil first. And so it will vaporize. This thermometer here placed right below where this connector is, that will tell you the boiling point of that liquid, and then that vapor is going to go through this tube, and then it's going to get cold. This part here is called the condenser, and you're running cold water through it. There's a tube inside of it so that your vapors aren't mixing with the water. Your vapors are just cooled by the water, and then those vapors will come down and they will condense into a liquid. And then you can collect your liquid down here, and it's called your distillate. And so this could be your alcohol. And back here in your flask, because we are still below 100 degrees, we have all of our water. Once all of our alcohol is distilled over, then we've got back in our flask our water, and we could go ahead and crank the temperature up and get it up to 100, and then our water would come over. But we'd want a different flask to collect it in so we could separate our mixture. Distillation's pretty cool. Okay, our last form of separating a mixture that we're going to talk about is called chromatography. It literally means color writing. And in chromatography, it uses two phases. It uses a stationary phase, the phase that doesn't move, it's a solid, and it uses a mobile phase that does move, which is usually a liquid or a gas. Now, the separation of your mixture happens because your components of your mixture are going to move at different rates through that stationary phase. So these components will have different affinities for the stationary or the mobile phase. We are going to do paper chromatography in a lab, and we are going to separate the different dyes that are in an ink pen. So here's a picture of paper chromatography. The solid phase would be this piece of filter paper. The mobile phase would be the liquid down here. It could be water, it could be alcohol. So somebody would have drawn a line. I'm guessing this was probably a black marker. Draw a line about here, and then they would dip it into the mobile phase, and the mobile phase would start to move up, and then it's separating all those different colors in that pen based on the affinity of the dyes in the pen for that stationary phase or how mobile it is in that liquid phase. So here it looks like the black was pretty soluble in our mobile phase, and it moved pretty high where the green stayed lower. All right, so in conclusion, know what mixtures are and know that they can be separated into their original components. And the three methods that we've talked about are filtration, distillation, and chromatography.